Hello everyone, welcome back to another Halo 3 modding tutorial. Today I will show you how to fully import any campaign mission, any multiplayer map, basically any map in Halo 3 into Blender. This method will also work with Halo 3 ODST and Halo 2. Halo 2 has a few different changes though, which I will address when we get to them. Halo 3 ODST is going to work the exact same way as Halo 3 does. Halo Combat Evolved has a different but easier method to import maps. Unfortunately, there is really no way to import Halo Reach and Halo 4 maps into Blender the same way you can with Halo 3. Um, Really, the only way to do that is by exporting the OBJ from Reclaimer, which you lose a lot of data doing that. Unfortunately, when tags were being compiled for Halo Reach and Halo 4, they did not include the importing info, which means that you can't extract the render models or the scenario structure, or I mean the .ass files um, from the tags, unfortunately. So this will not work with Halo Reach or Halo 4. Now, why may you want to import pre-existing maps into Blender? Well, there's a couple of reasons why. The main reason is to analyze for yourself the structure of a campaign map or a multiplayer map so you can better understand how to make your own. There may be other reasons. Maybe you want to um, go outside the bounds of a multiplayer map, even though you can already do that in Sapien. But again, the reason why I do it is just to better understand how to make your own maps. You can see how Bungie kind of made the original maps, or 343 made the newer maps, that kind of thing. What I will be showing you is we will be doing a campaign mission first, and then we'll be doing a multiplayer map secondly, just to show you the differences between the two. They basically work the same, but campaign, there's a bit more involved since it is a larger map with different loading, with different zone sets, that kind of thing. I will also be showing you how to import the skyboxes, which I believe is a very important part of a level. I will also be showing you how to set up the materials to match how the shaders look in game. So without further ado, let's get into it. The first thing we will want to do is that we will want to extract the JMS and the ASS files from the tags. So to do that, open up the editing kit directory. I have shortcuts here on my desktop. If you're doing Halo 2, open that 3 ODST, So what we want to do here in your Halo 3 editing kit directory, right up here in the address bar, you will want to type in CMD. This will open the command line, and we will be right where we need to be in the Halo 3 editing kit directory. So the campaign mission I will be doing will be the arc, which we will get. So we will go to tags, levels, solo for campaign missions, and not 100 Citadel, that is the Covenant. I will do 070 waste for the arc. You can do any mission you want to. Just know that Shadow, Forest, and I think that's it. Maybe tutorial as well. Just Forest and Shadow don't actually have any BSPs from what I know. These are cut content missions. You should be familiar with what these missions are. Intro is Arrival, Jungle is Hero 117, Base is Crow's Nest, Outskirts is Savo Highway, Voy is the Storm, Flood Voy, Floodgate, Waste, the Ark, Citadel, the Covenant, HC, which is short for High Charity, is Cortana, and Halo is Halo, Epilogue is Epilogue. So I will go to waste, and I will do, we're right here. We're right where we need to be. So we want to get the scenario structure BSP tag files here. Don't worry about scenario lightmap BSP data or scenario structure lighting info. From my understanding, those tags are generated by the game engine. So we'll just worry about scenario structure BSPs. So we'll go back to the commands line and we'll type tool, since that is the program we are using, then space. The command we want to use for Halo 3 and Halo 3 ODST will be extract import -info space, and then we want to specify the tag path. Now, if you're doing Halo 2, the command will be different. The command you'll want to use is extract-structure-data. So once you have that typed in, we will go back to the window explorer here, and we'll get the first one, 070 BSP 000.scenario structure BSP. We'll click on that. We will go back to the command line, and let's drag that in here, and that will give us the path to the tag. Now, if you're doing Halo 2, I'm pretty sure you will want to get rid of this file extension, file format extension, because since it is extract structure data, it already assumes that it's going to be a scenario structure BSP. So you'll want to delete this .scenario structure BSP. The reason you need to include it with Halo 3 and Halo 3 ODST is extract import info is a generic command for all different kinds of tag files, versus Halo 2, the extract structure data only works with scenario structure BSP files, so it assumes that the tag is already going to be a scenario structure BSP. So you only need the path of the tag and then the name of the tag itself. Once you have that, we'll do enter. That will extract the ASS file that is associated with that scenario structure BSP tag, and we will want to do that with all of the scenario structure BSP files. So what we can do is we can hit the up arrow on our keyboard, and we can scroll here. The next one is going to be BSP 005, so I'll replace this last 0 with a 5, hit enter. And you want to just do this over and over again for all the different scenario structure BSPs, so I will do that here quickly. Okay, so I've extracted all of the ASS files from the scenario structure BSP tags. The next thing we will do is that we will extract the skyboxes, and they are all located here in the skies folder, or the sky folder, I should say, and they all have their own folder. So don't worry about the bitmaps in the shaders folder, because those are just used to, of course, store the textures and the shaders. We will just do Sky 00, Sky 01, Sky 02, Sky Cinematics, and Waterfall. So we'll start with Sky 00, and this is a render model. So instead of a structure, instead of an ASS file, it will give us a JMS file. So for Halo 3 and Halo 3 ODST, we will use the same command. That will be tool extract -import -info, and we will drag sky00.render model to the command line. Now, if you're doing Halo 2, the command this time will be extract-render-data. And again, you will want to exclude the file type extension because that it's a specialized specific command for render models specifically, again, versus Halo 3's generic kind of all-encompassing tag command. So we'll hit enter, and we'll just do the same thing for all the skies. So we'll do tool space extract -import -info, and I'm going to hit enter just so we kind of have that saved, so we can just hit the up arrow to get that command. I'll go to sky 01 and I will drag render model into there, hit enter. I'll hit up on my keyboard twice to get that command back without the sky 01, and I will just keep doing this until I get all the skies. Okay, so I've extracted all of the render model tags for all of the skies. We are done with tools, so we can close out of command line. Actually, before we do that though, it'll tell us where it extracted the files to, which will be under data levels solo 070 waste, and then we have our different directories. So let's go back to Halo 3 editing kit folder, and let's go to data levels solo 070 waste, and here we have structure and sky. So now we can close out of command, and what I'm going to do is I'm going to make a folder on my desktop. I'm going to call this 070 waste. You can call it whatever you want to. This folder can also be anywhere on your computer. We're just going to put all of the files in this folder for easy access. So I will open this folder up. I will first go to the structure folder, and I will just copy all of these over to our new folder, and I'll do the same thing with the skies. Okay, so you should have your ASS files for your structure scenario BSPs and JMS for your skies. So I will just close out of this. Now what I will do is I'll go back to the 070 waste data directory, and we can just delete the sky and structure folder since we don't need it anymore. And we can close out of this window as well. So now we can go into Blender. So I will open that up and wait for it to load. And let's just delete everything. And let's get rid of the timeline here since we're not doing any animation work. Now, make sure that you have the Halo Blender add-on installed. If you don't, I have a video that you can check out how to install it. Just make sure if you do install it, you do need to restart Blender, or else the add-on will not work properly. So when you do that, in your Scene Properties panel here, you should have Halo Scene Properties tab. You'll want to open that up, and under Global Settings, depending on which game you are doing, you'll want to set it to that. If you're doing Halo 3 ODST, you'll set that to Halo 3 as well. What this does, this is a very important step because it will make sure when we import our ASS files and our JMS files that it will also import all of the important material properties, and each of these have different kinds of material properties, so you do absolutely want to make sure you select your proper Halo game before you do anything else. Now, I don't know if this actually does anything when importing files. I'm pretty sure this is only for exporting, but just in case, we'll go here to ASS. We'll set that to Halo 3 or Halo 2 if you're doing Halo 2. Same thing with JMS. We'll set that to our proper game. And JMA and JMI, we don't need to worry about it because we're not working with those files. So we're just about ready to import. Now, one final thing we want to do is we want to have a separate collection for each file we import, just to make sure that everything is separated and easily manageable. Now, one thing I will do is under filter here, I will just toggle disable and renders off since we're not rendering anything, but we do want to keep the eye and we do want to keep this view layer icon as well, and I will explain why later. So we will make a collection for each file. Now if we go back to our desktop and we open up our folder here, we can see the first one is 070BSP000. So I will name this first collection here in the outliner. I'll just name it BSP0000. And with that selected, I will go to File, Import, Halo Amalgam Scene Specification. And I'll go to Desktop where I have it, 070 Waste, and I will get that folder or that file and import ASS. Now this may take a while because there's a lot of stuff involved in an ASS file, so just give it some time. And that imported faster than I thought it would. So we have all of our objects here in our BSP000 collection. I'll just minimize that collection, but you'll notice we don't actually see anything. And that's because Halo, basically any model or anything you import from Halo is going to be gigantic in Blender, and that's just because the scaling in Halo works differently than it does in Blender. So what we want to do is we actually want to increase our view distance in Blender. And we can do that by clicking this arrow here and go to the View tab. And let's set end. Let's add 2 zeros to make it 100,000. And if we look around, you'll see that there is our map we just imported, but it looks really funky. There's what appears to be a lot of Z fighting, sort of. Just, it looks very glitchy. We can fix that by changing clip start to 1, and that will make it so it actually looks normal. So let's import the rest of the scenario structure BSP ASS files. Like I said, we'll make a separate collection for each one of them so we can better manage our project file here. So I'll click on Scene Selection and I will right-click, New Collection. The next one is going to be BSP005. So I will name this BSP_005. With that selected, I will go to File, Import, ASS, and import that. Again, it may take a little bit of time. And you'll notice that some things changed color. That's totally normal. What that means, why that happens, is because there are some materials, some shaders that are shared across different scenario structure BSPs, and it's just re-importing those materials. So you don't have to really worry about that. Doesn't really do anything. So I'll minimize that and I will make a new collection for each ASS file and import it. Basically just repeating the process until I get all of these BSP files. Okay, so we have all of our BSPs imported. You can see that it has filled out the space here, and I'm actually going to add I'll maybe put this to 200,000 so we can see a bit more. And we can see our entire level has been imported. Let's go ahead and let's import our skyboxes. We'll create a separate collection for them as well. So the first one is going to be Sky Cinematic. And these are JMSs, so they should import as armatures. So I will rename this as Sky Cinematic. And with that selected, I'll go to File, Import, and we'll do JMS this time, Jointed Model Skeleton. Under Version, let's go ahead and let's just set that to Halo 3 just to be safe. Do Halo 2 if you are doing Halo 2. Let's go to our folder. Let's do skycinematic.jms, and let's import that. Now, skyboxes are pretty gigantic, so they may take some time to import. There's a lot of, since they're armatures, there's like skin weight painting, or skin weights, that sort of thing, vertex groups. Just keep that in mind. These skies can take a while to import, so just be patient. Alright, that looked like it imported correctly. Before we do anything else, let's save this in case we get a crash, and I'll just name this 070 waste, and I put it in our folder on the desktop. Save that. And one more thing I do want to do. Well, before we do that though, we can see our sky, but we don't see all of it. Let's change this to right here in 200,000. Let's change that to a 10, and we should be able to really see our skybox. It's still really huge, and these faces kind of go past our view distance, but whatever, that's okay. We don't need to see all of it. In fact, I'll keep that as is for now. But depending on your machine, depending on the strength of your machine, and depending on the level, the map. Some maps can get pretty huge in triangle counts, polygon counts. And depending on your machine, you might experience some lag. This only works with collections, and this is part of the reason why we set up a collection for each BSP, is you can just click this button here, this checkbox, and that will remove it basically from memory. From what I understand, there's a difference between the eye. The eye hides it, but I don't think it actually removes it from memory, so it's still loaded in. This checkbox here, you can click that, and that should that should free up some lag if you're experiencing lag. I'm not. I have a pretty decent, okay computer. Like I said, this box only works for collections. You can see that box isn't there. So that's why we still have the visibility icon, hide in viewport here, when we want to do that with objects. So I'm going to unhide the sky cinematic here, and I'm just going to add in the rest of the skyboxes. Okay, so we have an issue here. It didn't import as an armature. So, I'm not sure exactly why this happens. I'm going to try something that might fix this. This might be an add-on error, this might be something I'm doing wrong, but what I'm going to do is I'm just going to go here just to clear up this, if we delete it, some of the data will still be there even when we delete these objects. So I'm just going to go to File. I'm going to click Revert here. That's going to take us back before I imported the Sky Cinematic 02. Revert basically just, as it says here, reload the saved file. So I'll click Revert. I'll add that back in. Sky Cinematic, I think it was 01. Let me double check. Yep. And under File, Import, I'm going to change this to Halo 3, version to Halo 3, but I'm going to uncheck this reuse armature box. I have a suspicion that this may be the culprit for why it's not importing as an armature. So let's see if that fixes it. So I will import Sky Cinematic 01 again. Import. Okay, that did seem to fix the issue. It did import as an armature, so I'm guessing that Sky Cinematic and Sky Cinematic 01 basically share the same node parent in the game engine. But since we imported it as a separate collection, it couldn't parent the objects to this armature, so it just imported without an armature, so that's, I guess, what happened. I will go ahead and import the remaining skyboxes. Okay, it appears like everything imported normally. This waterfall here did not end up in the place that I thought it would. But whatever. I'll just let's take a look here actually. Let's see if the armature, let's see where that armature is. So the armature looks like it's at the origin point. And the sky waste is a bit above the origin point. Okay, well, I'm pretty sure skyboxes, their origin points are all at the world origin point. But you can see here these mountains and stuff are part of the skybox. These plains are like for clouds, that sort of thing. I'm going to just hide all the skyboxes. So this is the entire level. Now, you may be wondering what these planes are in these boxes right here. These are actually very important objects to the structure of a map. So this right here is a skybox, and you can see it's marked at the object name is 00 sky. Depending on the map, the sky may not be a separate object. The reason why this is when you make an ASS file, when you export an ASS file or export an FBX and then like convert it into a BSP structure file, it kind of combines all objects into one. And that's kind of an important concept to understand. If you know about the general structure of a Halo map, you know that they have to be a closed environment. There can't be like any open faces or seams or anything. It all has to be like a closed in shape. And the skyboxes are basically the outer bounds of the basically the game. You can't go further than the skybox, than the skybox object here in game. or in engine. You can, but things kind of start to break noticeably when you're in Sapien. Um, you'll start seeing different things. Now, we can hide these objects. Um, so let's go ahead and up here in the search in the outliner, let's do plus sky. And that's going to show us every object that has a sky material on it. You can see we have plus sky 00. Now, I highly recommend going to the Reclaimer's library website, and under Halo 3 Blender level guide, it'll tell you, it'll talk about multiple skies here. So we have plus sky 00, plus sky 02. I recommend reading up on this. And right here, again, in on the Halo 3 materials page, you'll see skies. So we have plus sky. Basically, the plus followed by a certain keyword tells the game engine that this is a special kind of material. So sky, right here, apply to surfaces to render the skybox. So this material basically tells the game engine that apply this, render the appropriate skybox, whatever skybox is assigned to a certain zone set. Render that skybox. But I'll go back and I'll search for sky. Let's hide all of these objects here that have the sky. The sky material so we can better see our map. We may not want to hide these doors small. We may just want to hide only the objects that specifically say, like, that are obviously just the skybox. We may not want to hide this BSP-080 either, because that might include certain collision or render objects or sections. Now, these faces here are called portals. Now, portals have multiple uses. The two main uses you'll come across, and I'll cover this more in when I make a Halo 3, like you're making a custom level from scratch. I'll probably cover this. I will cover it in detail in that video because portals are very important. They are a required part of the map making process. Because what portals do, and you can read about portals in the Halo 3 Blender level guide. Portals, you can read up about them here. Basically, they cut up the geometry into chunks so the game engine can better handle them and load them and load them in and out. Portals are not just in Halo games, they're in all games. But here you can set up, in the Halo map making process, you set up portals manually. Portals, like I said, they're made to cut up the geometry into manageable sections for the game engine. But they also have a second use. And right up here, in the outliner search bar, instead of plus sky, I am going to type in plus portal, and that'll show us all the objects that have the plus portal material to them. So let's hide these, and you can see we're already able to really see the level better. Right here you'll see Z sound. I'll hide this. If we look right here, you can see in this cave section of the map, we have two portals. And this object is called Z sound 000 because one other purpose, one other use of the portal plus portal material is that it's used to block sounds and modify sounds. So when you go in this cave in the game, you don't really hear the wind like you do if you're on the outside, and that has to do with these portals here. So when we're analyzing this map, though, we don't really need to see our portals, really. You can set up, when you're making your own maps, you can set up portals however you want to, as long as you meet the requirements of, like, chunk sizes with properly cut sections with portals. And if that doesn't really make that much sense, that's okay. That's kind of out of the scope of this tutorial anyway. So we'll just continue on by hiding these objects that are clearly just portal objects or clearly just sound objects. Now, one thing you might notice is that it looks like these portal objects are the same, and that's because they are. They're BSP structures, ASS files actually will share the same objects when they're exported separately. So these objects are literally the same, and the .001 isn't actually meant to be there. The thing about Blender is that it was not used originally for making Halo levels, Halo maps, so that's kind of one discrepancy there. I hope that makes sense. The final thing I want to show off, and this kind of goes back into the ASS files will share the same objects, are these loading seams. So here's one right here in this cave entrance. You can see it's called Z seam BSP 005. If we hide that, you'll see we have basically an identical object, and that's because it is the same object when it was exported, but when we imported it, it created a duplicate because both ASS files shared the same object. So, well, actually not necessarily, because if you notice here, this one is 005, and the other one is 000. So what these seams are is that they break up the level geometry, the BSPs, the zone sets, as they're called in in Gorilla and Sapien. So whenever you're playing the game and you see on the bottom left quadrant of the screen, it says where you typically have like this player killed this player or picked up shotgun or whatever, and it'll say loading ... done. That happens when you cross these seams. And you'll see that they are named differently because one of them is for loading BSP 000, which is this area, and one of them is for loading BSP 005, which is this interior section right here. In fact, I'm going to hide that portal right there. For whatever reason, I did not hide it when I looked for it there. We will unload all of the BSPs except 005, but before that, I do want to go over one more thing, and that's instanced geometry. So, some geometry will have these symbols on the front of the object name. And right here in the Halo 3 Blender level guide, you can see what these symbols mean. So for example, if we look at this, it has a percent sign, an exclamation mark, and a hyphen. So the percent means it's an instance object prefix. And instance objects are very specific. They're very important objects, and I will explain exactly what they are. Some symbols are specific when used in conjunction with instance geometry. So the exclamation mark, since it's a instance object, it's not this exclamation mark, it's this exclamation mark. This exclamation mark means light object per pixel. I will not explain what that means because that's out of the scope of this video. And this hyphen, not pathfinding prefix. Usually the terrain is not instanced objects, so you will not see a percent sign there. Instance objects literally mean just the same object, but copied multiple times. So if we take a look at this tree here, we can see it's an instance object. And if we go to the mesh, the object data properties panel, we can see that the name of the mesh is 59. Well, I'm pretty sure this tree right here is the same object, but instanced. And you can see that it shares the same mesh data, and that's because it is an instance object. And in Blender, if you don't know the difference between duplicating an object and duplicating linked object, where instead of duplicating an object, you're instancing an object, I would highly recommend learning how, understanding what that means. Basically, in Blender, when you press Shift D, you're duplicating an object, but it doesn't share the same mesh data. It shares separate data. Versus when you press Alt D, you're instancing an object, so it shares the same data. So between, if you were to just regularly duplicate an object and you were to make changes to one, those changes would not be reflected in the duplicate object. But if you duplicate linked or instance an object and you edit the mesh of one, the same edits will be made in the instanced object. Now, instance objects can have different locations, rotation, basically different transforms, because that's part of the object information, not the object data information or the mesh information, but the object information. So they can be scaled. The power of it is you can create copies of an object, but make them appear differently by scaling them, by rotating them, by placing them in different areas. So that's the importance of instanced objects when it comes not only to Halo, but to Blender itself. All right, so we fully imported the Ark mission, and you can see this is our starting area. This is the area with the crashed pelican. This is the area with the longsword, the crashed longsword. This is where Commander Keyes lands the forward onto Dawn. This is where you go through the wall. This is where you fight the scarab, and this is the final section. And you can see that this level's just one big rectangle, which is one cool thing about importing the level, is that you get to really see it all. So next I will show you basically how to recreate the shaders in Blender so you can really make the level kind of look like what it looks like in game. And to do that, I'm just going to show you a few examples. So I'm going to unload all of these except for BSP005, which is just this small interior location with that one Forerunner terminal here. And there's one specific one I will start with here, which is this door. Now, this door has 4 materials, and you'll notice that these materials start with either waste or sit. Now, these first words are actually known as shader collections. And what shader collections allow you to do is they basically allow you to save hard drive space by limiting the amount of times you have to copy materials from one map to another. If you want to use the same material or the same shader, in other words, across multiple maps. So I will open up Halo 3 editing kit here, directory. And when you usually it's required when you have a shader or a material, that material has to be in the if we go to solo here and we go to waste, all the materials that we have to use, I'm not in the right. Here we go. Solo waste. Okay, so all of the shaders that you use, aka all of the materials you use across your map, it's required that they have to be in the shaders folder in your map. But what if there's a material that you want to use from another map, but you want to save space on your hard drive, you want to basically, you don't want redundant data. You don't want to deal with redundant data. Well, you can use shaders from another map using shader collections. So let's say I want to use a shader from 100 Citadel, which is the Covenant. Well, I can just add the prefix sit here. Well, what defines these shader collections? Well, if we go to tags levels here, there's a text document right here titled shader collections. And right here, you can see where where the words are defined here. So you can add your own, like if I made my own level called poop, and or I don't think it can be, I think it has to be one thing, so I could type, I'm pretty sure I could name it poop and pp. I would just put the path to the map that I made. So, for example, waste here is level solo 070 waste. And that will point to the shader folder that is inside of waste. It'll point to this folder. And you can add your, like I said, you can add your own shader collections here. Here we go. Sit is 100 Citadel, which is the Covenant, which is right here. So that's what shader collections are. Now, one other thing you may notice with this first material is that it has a symbol at the end, which is this exclamation mark. So let's go here to Reclaimer's library, to the Halo 3 materials page. And under material symbols, we will see the exclamation mark is render only. And right here it says material symbols are added to the start or end of the material name and give the surface certain attributes or behaviors in engine. So we can see that this is a render only material. But if we scroll down, we'll see Halo material properties panel right here. It's checked. And if we go to flags, this render only option is also checked. I I don't think it is required to have both of these symbols. I think you can either have no symbols and have it checked, or you can have no checked and have the symbol. But just to be safe, I would, when you're making your own map, I would make sure you have the symbol and you would have the option here under flags checked. Now, let me save real quick. Now, remember back at the beginning of the tutorial, I said under global settings, make sure the scene version is set to Halo 3 or Halo 2 if you're working with Halo 2. The reason why you want to do this is that Halo Combat Evolved, Halo 2, and Halo 3 have different material properties. So if I were to set this to Halo 2, it would give me a completely different list of options here. So that's one of the reasons why you want to set the global settings and the scene properties to your correct game. Now let's take a look at this second material here. You'll notice that it's Waste Metal B001. So that tells us that there are duplicates of this material. Now, you may be tempted to go across all your objects and for each duplicated material, set it to the original one. But that will break things because they're actually duplicated for a reason. If you look right here, again, under Halo material properties, you'll see that under the name override, it actually will, when you export the ASS and you compile it into a BSP scenario structure tag, it will give this material this name. Instead, it will override it. And there's reasons why there's duplicates. These duplicates may have different flags checked, or they may have different light map property settings. So if we were to look at Waste Metal B here, it doesn't have the material override because it's the original name, but you can see that this one is render only. The first one we looked at, which was 001, was not render only. So that's one reason why these are duplicated. All right, so let's get into actually recreating the shader here. So first, let's look at SID glass control. Now, this shape, this light blue cyan material, if we go down, for some reason it doesn't have the symbol. The symbol is an @ symbol for collision only. But if we look at this, you can see that it is marked collision only. So actually, we would not see the mesh that this material is applied to in game. So unfortunately, there is no way to hide only this material in solid mode, display solid mode. But we can do it in material preview mode. So let's change to that. And under here in settings, let's change blend mode to alpha blend. And let's change shadow mode to none. Now that doesn't do anything. And that's because we actually need to activate use nodes here. So I opened up a new window here. I dragged up a new window. And let's change this to shader editor. And we can either click here on this checkbox or we can click here to use nodes. Let's do that. And now you can see that it went from cyan to white. And that's because the base color here is white. But since we don't actually see this in game, let's change the alpha here to 0. Now we can actually see what the door looks like in game. We can see that we can still kind of see the wireframe when we select this object, we can still see the wireframe of this collision only mesh here. Or collision only material, I should say. But let's recreate this blue shader right here. So this is waist door frame small, and it belongs to the waist shader collection. So we know that it is in the 070 waist shaders folder. So let's go to Reclaimer. And in Reclaimer, we're going to use Reclaimer to get the textures. So let's go to File, Open Map, and you want to go to not your Halo 3 editing kit, but the actual Halo the Master Chief Collection game to open the map file there. So I will go to my Steam library, Steam Apps, Common, Halo the Master Chief Collection, Halo 3, Maps, and I will open up 070 Waste. And now I'm going to open up Gorilla here, because we can go to Levels, Solo, Waste, and we have the shaders here, and we'll be able to open up the shader tags. Let's go ahead, let's go back to Blender, and let's do Use Nodes. Now we want to look up waist door frame small. We want to look up that shader. So in the shaders folder here, waist door frame small, here it is. Let's open it up. And here we'll be able to see what textures are used and how they're used. So we know under Albedo here, base map, waist door frame small. It's the same name as the shader. That's not always the case. Sometimes the texture maps will have a different name from the shader. But here we have waist door frame small. So back in Reclaimer, we can look up waist door frame small, and it'll give us two folders here. It's not the shader we want, it's the bitmaps we want. And here's the bitmap, so we can open that by double clicking. And very important here, we want to export all channels. We want to export the alpha channel. So we want to export all channels. And I'll put that in our desktop folder. But I'll make a new folder called bitmaps, just to separate the bitmaps from the BSPs and the skyboxes. I'll do save. And right here under bump mapping, back in Gorilla, it also says waist door frame small bump. And it's right here. So I will save this as well. Now, we take a look here. Actually, let's go to Blender before I explain what I was just going to explain. Let's go back to desktop, and let's get our bitmaps here. Let's drag in both waist door frame small and waist door frame small bump. So let's put our color into base color, and we'll be able to see the texture. The shading looks really flat though. Part of that has to do with the fact that we don't have the normal map set up, but also if we take a look here at Gorilla, it'll say right here specular mask from diffuse. And what that means is that the alpha channel of the waist door frame small map actually stores the specular data of the door. So right here, the alpha channel, we can drag this into specular, and you can see it's changed quite a bit. It looks a lot better. And one thing I do like to do, I don't know how accurate this is, But one thing I like to do is I also like to drag this into roughness, the alpha to roughness. But that does give us an issue. Uh, because roughness maps are meant to be white means rough and black means smooth, this we actually need to invert this. So we'll go to color invert, and now that's looking a bit more correct. So now our black is rough and our white is smooth. So that's looking a lot better now. Now, one thing, we have one more thing, we have the bump map here. Because it's a normal map, we want to change color space from sRGB to non-color. And I will add in a vector normal map node, plug this color into color and normal into normal. Now, it might be hard to notice the changes, so if I get rid of specular and roughness here, you can see that our bump map adds even more detail. Now, one thing to note is that this is a DirectX bump map, a normal map. Blender uses OpenGL normal map, so this isn't totally accurate, but I'm not going to bother converting the DirectX bump map to an OpenGL bump map because that would just take too much time, and for the sake of this video, this setup is good enough. So we have a material here that looks pretty accurate. One thing though I forgot is that right here we have an albedo color. This kind of gives the metal a yellowish desert tint. So let's add that as well. Unfortunately, when we click on this, there's no way to get the hexadecimal code for the color. So what I like to do is I like to take a screenshot of Gorilla here by pressing Alt print screen on the keyboard and then opening up paint.net or any image editor of your choosing. Paste the screenshot, and with the color picker tool, I'll just click on the color here, go to more in the colors window, and then copy the hexadecimal code here. And then in Blender, I'll add a mix color. And I'm going to set mix to multiply. I think that's a bit more accurate. Bump the factor all the way up. And then change from hex here. Paste that code in. And since this is such a small change, you won't notice it here. But let's take a look at another shader over here. It should be, I think it's sit panel hall doorway. This might be it, actually. I think it's this one right here. I think it's this light blue. Okay, it is. So let's take a look at this one right here, this light blue material. We're going to click on Use Nodes again to set this up. And let's take a look at Gorilla. So I have the waist panel wall inset decor blue shader tag opened up here. You can see that's the same material here. And we have a base map. We have a detail map. Well, there's no detail map, but I'm not entirely 100% sure how to replicate the detail maps in Blender, so I will not be covering detail maps in this video. But we also have a color mask map along with the bump map. And this is still a specular mask from diffuse, so we have the specular data in the alpha channel of the base map. So let's find these textures and reclaimers. So the first one is waist panel wall inset. we can get rid of these. Waist panel wall inset. Here we go, waist panel wall inset. There we go. Waist panel wall inset albedo, or albedo. And waist panel wall inset bump, we'll get that too. There's also a parallax here. And right here under parallax, we can see that I don't fully understand how parallax works. I know it's a height map, as you can see here. So what we would typically do is that we would put that height map here in displacement with a vector displacement. Or not vector displacement, but displacement here. We would plug in the texture to height. But one thing I don't understand is that for some reason it's blue. That's tinted blue, and typically height maps are just grayscale. So I'm not 100% sure why that is or how it works necessarily. So I won't worry about it in this video. But let's get these textures here. Let's export the bump map. Export it in that same folder. Export this, and you can see it's red, green, blue. This is the albedo map. And then we will export the usual diffuse one. Alright, so let's import those textures into Blender here. Let's just do one at a time, though. So here I'll do the same thing I did with the other one. Now, one thing I need to point out, but before I do that, I'll just do specular and roughness here. And add invert. One thing you'll notice is that this isn't looking quite right. It's looking stretched. That's because if we look here, the base map scale X value is 2, and you can see that's across the color mask map and the bump map scale as well. So I have the node wrangler add-on enabled, so if I do Control T, it'll set this up. If you don't have that enabled, just add in a vector mapping node, and then add in a input texture coordinate node, and you'll want to connect them like this, with the UV into vector and the vector into vector. And so since that X value in Gorilla was 2, let's change this X to 2. Now you can see it's not looking stretched, but it's still not looking quite right. It's tiling like it's supposed to, but it's not mirroring like it's supposed to. You can see here that base map wrap mode X is set to mirror across these textures as well. And unfortunately, Blender does not have that available. It has repeat, and it has extend, and it has clip, but it doesn't have repeat, or it doesn't have mirror, unfortunately. There's no way to fix that unless you actually edit the mesh itself or edit the UVs. So that's just one thing to keep in mind. Let's go ahead and let's add in the bump map next. We'll set color space to non-color again. And let's add a normal map node. Connect all that up. You'll see the normal map doesn't quite line up, but that's simple. We can just do that, and it will line up. And now let's go over this albedo map. So Let's drag it in. And you'll notice that there's red, green, and blue and black. Well, the reason why it's like that is because we can use the different color channels here. If I go to converter, and I do separate color, and I do color here, it'll separate the red channel, the green channel, and the blue channel. And if we go to Gorilla here, you can see that there is albedo color blue, albedo color 2, and albedo color 3. Now, I'm pretty sure that this corresponds. This first one is red for the red channel, the second one is for the green channel, and the third one is for the blue channel. So let's try that. I could be wrong about that, but that's usually how it goes. So I put vector into vector here, so it has the same UV transform here. I'll add a color, mix color, and we'll do the same thing that we did before. Multiply, bump it up. Actually, we don't want to bump it up. What we want to do is we'll put red here into the factor. And we'll get our first color here. I'll do Alt print screen to take a screenshot of Gorilla. And I'll paste it into paint.net and get the color picker tool and get this color. Now, one thing I'll do is I'll create a new window here by dragging out and dividing this into two, and I'll get a UV editor. Let's take a look at this albedo map. So we want the red parts of this texture to have that blue color. So let's try B. I'm not 100% sure if it's A or B that we need to change. So let's try B first. I'm pretty sure it's B. And it's really hard to tell exactly what it made changes to. So let's make a really ridiculous color here. You know what? It didn't change because we forgot to add the result to base color. And as you can see, that actually worked the way it's supposed to. You can see that the red section of this texture has that blue color. So let's add the last two. So we'll add the green channel next. And we'll want to plug the result of this new one into A. Let's drag this out a bit more. Now, let's take the green and put it into the factor this time, and we'll change the B to this color of albedo color 2. And change that, the B. Now let's do the blue. And then we'll do the black area last. So we'll add that in. But let's change this to blue. We need to reapply this green node here to the factor because that kind of screwed it up. It didn't do the nodes correctly. We'll plug this result into A of the green. And we'll get this golden color here. And put that into B. And you can see now the blue parts are that nice golden color that we expected. Now the black, I'm pretty sure is this neutral gray. And neutral gray typically means Well, it's already set to half, but let's make it a darker one. Let's set it to like 0.1. That doesn't look quite right. Well, that's for this video, that's probably okay. I don't know exactly what this neutral gray is necessarily. But that's kind of how you get these albedo maps working. So we have that. There's one more material I want to give an example of, and it's this window material right here. That it's sit glass control. So we actually need to go to the Citadel map here. And under shaders, we'll look for glass control. Here we have glass control. We see it doesn't have a bump map, but it has an albedo map and it has a specular mask. And you can see right here, specular mask is set to specular mask from texture and not specular mask from diffuse. Basically what that means is that instead of the alpha channel holding the specular information, it's actually holding the transparency information, and I think that's defined here with blend mode alpha blend. So we'll look for glass control and glass control specular. And even though those are Citadel textures, they're still baked into the map file. So if we do glass control, we do bitmap, you can see that it has the path of Citadel. But let's just get these. So we have specular and glass control. Let's export all channels for both of the textures. And let's go ahead and let's just put them into Blender. So we can get rid of this UV map window, get our full shader editor window back. We need to activate use nodes. And let's first add in the glass control diffuse map. Let's put color to color, and like I said, the alpha channel actually holds the transparency information. So instead of connecting to specular and roughness, we want to connect alpha to alpha. But that's not going to look quite right here. It's going to give us like this ugly, fully dark splotchiness going on, and we actually need to go down here in the panel, material panel. We need to scroll down to settings. We want to change blend mode to alpha blend. And that's automatically going to look a lot better. We can actually see through it. We can see the detail of the textures. And you can set shadow mode to alpha clip or alpha hashed. I'm just going to set it to none because you don't really notice a difference. Or at least I don't. And let's just add in that glass control specular. And this, the color right here, is what we're going to want to plug into specular. And if you want to invert it and plug it into roughness. And you can see that's the same texture on the floor here as well. And we can actually see through it and see that mesh on the other side. So there we go. I showed off how to do 3 different materials here. I would recommend that if you really want to go through and add all the different materials you see. There's one other material, major material I didn't cover, and that's actually shader terrain. When I go over the multiplayer map, I will show an example of how to do the shader terrain material. But yeah, there we go. Let's load this all back up. And for some reason, it revealed the portals and the skyboxes, which I didn't want, but whatever. I guess if you exclude from view layer instead of hiding it, it might unhide all of the things that you hid before. I didn't realize that. But yeah, one other thing you should probably know here. Let me actually deactivate all these again. And where's our... There it is. Let's look at our door again. One thing I would recommend doing is, in these cases where you have these duplicated materials, what you would probably want to do is just copy your node tree by selecting it with box select, just by dragging over, and do Control C to copy it, and then go to your other materials and then just Control V pasting it, just so you don't have to do the entire node tree from scratch. But let's go ahead and let's move on to a multiplayer map. Okay, so now we are going to do a multiplayer map, and the multiplayer map I'm going to show in this video is going to be Sandtrap. So, what I'm going to do is go back to Halo 3 editing kit directory, go to, we want to go up here in the address bar, type in CMD to open up command line, and let's go find Sandtrap. It'll be under tags, levels. It's going to be multi. Atlas is unused as technically for Halo 3 ODST, and if you're modding Halo 3 ODST, all of the level files are going to be in Atlas. DLC is for any DLC maps or mythic maps. Multi is for any retail maps, and Sandtrap is going to be here, and it's going to be Shrine. So let's do tool, extract, import info, and again, if you're doing Halo 2, it's going to be the two different commands without file extensions. So I will drag shrine.scenario structure BSP into the command line, press enter. That put it in the data folder, the data directory. Let's get the sky as well. I will do the same command, but with this render model, sky render model, and hit enter. We can exit out of command line and go back to Halo 3 editing kit, data, levels, solo, not solo, multi, go to Shrine, and let's make another folder on our desktop or wherever you want it. Call it Shrine or whatever you want to call it. Let's drag the sky in, and let's drag the structure in. Can close out of that. Let's go back to the Shrine folder here in the data directory, and let's just delete the sky and structure folders. We don't need them anymore. Can close out of that. Now let's open up Blender. Let's delete everything, get rid of the timeline. Let's set Halo scene properties. Let's go global settings. Set this to your Halo game that you're modding. Halo 3 for Halo 3 ODST. ASS scene properties, just in case. Let's set this to Halo 3 MCC. JMS, just in case, to Halo 3 MCC as well. Let's rename collection here to, since multiplayer maps only have one BSP, they only have one zone set. Unlike campaign maps, that have multiple zone sets, multiple BSPs, multiplayer maps only have one zone set, one BSP. And as the Reclaimer library says, if you're making a multiplayer map, do not attempt to have a multiplayer map with multiple BSPs, multiple zone sets. So since we have one zone set, let's just rename collection to BSP. With that selected, let's go to File, Import, ASS. Let's find our Shrine folder. Let's open up shrine.ass. Import that. And let's minimize that collection. Let's add another collection. Name this to Sky. And with that selected, we will import the JMS of our Sky. For version, let's set that to Halo 3. Let's uncheck reuse armature since we had issues with that earlier. Even though we will only have one JMS, let's select that and import JMS. Okay, Sky imported like it's supposed to. Let's take a look at the Sky real quick, but we can't see it, so we need to change our view distance. So open up this tool panel here, go to the view panel, set clip start to 1 and end to 100,000. And we still can't see the Sky, so let's add one more 0. Now we can see the Sky. And if you want to, you can select the Sky mesh. You can see that typically Skies and even BSPs will have lights. You can add lights, and you definitely should if you're making your own multiplayer map. But let's just worry about the mesh. If you want to add textures and stuff, it's the same process, looking up the shader in Gorilla, but in this case, since it's a Sky, you would go to the level directory here, Shrine, and the shader should be in the Sky folder. And you can see there's Sun Disk, Sky Dome, you can see those are there. So there you go if you want to add the Sky textures to any map. But now let's worry about the BSP. BSP, we got a massive portal here. Let's hide the portals. So let's go to, let's search for plus portal. Let's hide all these portals here. There's only 4 of them here in Sandtrap. And let's hide... We can't hide the skybox without hiding the terrain. That's what I was talking about earlier, where sometimes the skybox is the same mesh as the terrain, so we can't hide the skybox, unfortunately. But the one thing I wanted to show off with this multiplayer map is the shader terrain type material. And usually you'll find that on terrain, of course. You'll find it on cliffs and that stuff, but it's also here on these buildings, lack of a better word. if you've played Sandtrap, you'll know that there's like these corners are weathered down, and the way they affect that, the way they do that is through the shader terrain. So I'll show you how to set up the shader terrain material in Blender. So it's going to be this Cust Stone Pyramid 1. Let's get a new shader editor window open here, and let's enable nodes. Now, let's take a look at, in Gorilla, let's look at Shrine. Under shaders, it's going to be Cust Stone Pyramid 1 dot shader terrain. You'll notice it's shader terrain this time. Now, shader terrains are broken up usually into 4 different materials. And the way that works is I will show you if we open up Reclaimer again. We'll get the textures from here. Let's open up Shrine in our Halo the Master Chief Collection install. So we'll go to Steam Library, Steam Apps, Common, Halo the Master Chief Collection, not the editing kits, but the actual game. Halo 3, Maps, and it's going to be Shrine.map. What we want to look for is the way that these different materials are broken up is with the blending map. The blending map works pretty much the same as the albedo map when I was showing that to you on the Arc campaign mission. So we want to look for this blend map. It's going to be Stone Pyramid 1 blend. So let's look for it. Stone _ Pyramid 1 blend. And there it is. You can see it's broken up into red, green, blue. Let's export these channels. And let's export it to desktop. And let's save it. Let's create a new folder in our Shrine folder, bitmaps. And let's save that. And let's do the rest of the textures as well. So we're going to have, for the sake of time, I'm not going to worry about the bump maps. I'm just going to do the base maps. Let's do stone laminate diff. Laminate diff. It'll be this texture. Stone broken diff. These textures should probably start to look familiar. And stone laminate pitted diff. Stone laminated pitted diff. Now, one thing you will notice here is that there isn't a 4th one. Material 3 is turned off. Now this, I'm not 100% sure about this, but depending on how it's set up in Sapien, because I'm pretty sure that this blend map is actually painted in Sapien. Depending on how it's set up in Sapien, these different ones might be out of order. So it might not be red, green, blue, alpha. It might be green, blue, red, alpha, or alpha, red, green, blue, you know, that things. So let's actually open up Sapien and let's see if we can figure it out here. So, Sapien. And let's open up Shrine. And let's give it a minute. But while we wait, let's go ahead and let's import our textures. And I won't worry about specular either, for the sake of time and for actually the sake of my computer's resources, because if you have like a really big tree going, you can really crash Blender easily. Now let's save this. Let's save what we have. We'll save it as Shrine. Let's see if it's done loading yet. It is not. So let's find our stone pyramid blend and let's go ahead. Let's add converter separate color. Put color there. I should also point out, if you take a look at the blend, as I pointed out here in Gorilla, Material 3 is off. If Material 3 was on, you would probably see Alpha channel as well, but we only see red, green, and blue. Okay, it took a while, but it's loaded up. Let's take a look here at what we are looking at. Let's look at structure data. Structure painter. And, Stone Pyramid 1 blend, I think. Yep, here we go. So, red channel is going to be, this stone laminate diff. Oh, now it changed on us. Come on. Maybe let's try exiting and go back to structure painter. Hello. Oh, it's not wanting to work with us. Here we go. Stone pyramid blend. So, red channel is going to be the smooth one, green channel is going to be rough, and blue channel is going to be the pitted, I believe. So, let's see if that's actually reflected in... It is. So, material 0, 1, and 2, they are RGB. That may not be the same for all shader terrain types, though. Just a fair warning, I'm not 100% sure about that. So, what we want to do is we want to go back to Blender. Let's add a color, mix color. Let's set factor, let's drag red to factor. Let's go ahead and let's plug the result into base color. Let's go to material preview mode. And stone laminate diff. Let's plug that into color B. We can see it's already starting to take form here. But I'm pretty sure we need to change the we need to change the UV transform scale to 10 on X and Y. So I'm going to do Control T and put scale to 10 on X and Y. Now that's starting to look a bit better. So next I will add in the green channel, but that's going to mess it up, so let's fix that here. Green's going to plug into there. And this one is going to be the rough one, the broken. So here it is, stone broken diff. We'll plug that into B. And that's starting to look good. So let's see what the transforms on that are. That's going to be uniform 5. So we'll duplicate this mapping node and we'll plug UV into vector, plug vector into vector, but we want to change X and Y to 5. Now that's starting to look good. And now the last one's going to be blue, but we don't really need to make another mix node because the only ones that are left, the only thing that's left is blue, so we can just plug this last one into A. So let me drag these down, these nodes down, so we have room for this node. Let's plug that into A. And what are the transforms on that? That's going to be 30. So let's duplicate this mapping node, plug UV into vector, set X and Y to 30 on scale, and plug vector into vector. And that's looking pretty darn good. Now, if you wanted to do the bump maps and the specular maps, you would do the same thing here as we did, but you would need separate mix nodes. So actually, why don't I just show that off? We won't do the bump map because that's going to be that's going to put too much strain on my computer, I believe. In fact, actually, you wouldn't do the mix nodes with the normal. That actually would be incorrect, I think. Actually, no. No. You know what? Let's do it. Let's do the normal map. I won't do the specular map, but I'll do the normal map. If you want to do the specular map, you would do the same thing, but you would plug the alphas in instead. Or any related specular map. So I will get we can close out of Sapien since we know the order, the proper order of this. So let's get these bump maps. I am gonna save the blend file though. We want to get stone laminate bump, stone laminate pitted bump, and stone laminate bump. So let's save these. And then we want stone broken. Stone broken bump. Okay. Now I'm going to save. Alright, so let's put these normal maps together. So we're going to basically duplicate these mix, and I'm going to route these the same way as we did. And let's go ahead, let's get a vector normal map. Let's get this last mix node, let's plug that into color, and let's plug normal map into normal. And that's not going to do anything for us because we don't actually have the normal map set up. Let's get rid of these extra ones. Now, let's get our, let's first get the laminate, the regular one, not the pitted one. Let's plug that into B. And the vector, the UV transform should be the same, so let's just plug that into vector there. And we want to change color space to non-color. That's not going to be the right mapping node, it's going to be this one. And let's get stone broken bump, that's the next one. Let's set this to non-color. And let's plug vector into vector there. Let's plug this into B. And this is going to be a total mess of a node graph. Definitely organize this better than I am. Get some like routing nodes and to really make this look better. That's looking like it's supposed to. And finally, let's get this last pitted bump. Let's put it out here. So it doesn't cross with these. And let's drag that into A. And we got the normal map set up like it's supposed to. Again, you can also set up the specular, and definitely if you really make this a full graph, you're going to want to join these in a new frame, or join group nodes together, make things look a lot better than I have here, but for the sake of time, I'm not doing that. We'll save. And again, these shader terrains, they're going to pop up for usually ground, terrain, cliffs, these things. You can see these are properly textured. So yeah, that will do it for this video. I hope this was a useful video. You learned a lot. I know this is a long one. This is definitely a long video. But yeah, like I said, hope you learned a lot. Hope you learned how to utilize this to make your own maps, multiplayer, campaign, whatever. And look out for more Halo 3 or Halo in general modding tutorials in the future. Thanks for watching. Leave a like and subscribe if you found value in this video. Sorry it was a bit of a long one, but we covered a lot in this video. That'll do it, so I will see you next time. Goodbye.